Okay, so I will first go through the trigonometry notes. Okay, so first, Pythagoras theorem applies in this way: a squared plus b squared is equal to c squared. So c squared refers to the hypotenuse, which is the longest side, and opposite, and the other two sides, which is the sides which touches the right angle, is a and b respectively. So for example, we can put this a to be 3, b to be 4, and c will be 5. So some 3 square plus 4 square will be 5 square. So longer side is 5, which is C, and this can be A, and 4 can be B. All right. So for this, it applies for right angle triangle. Right. Right angle triangle. Okay. And now we can move on to explaining what is torcaso. So for torcaso, we can remember is T will stand for tangent, C stands for cosine, and sine stands for, letter S stands for sine. O stands for opposite, A stands for adjacent, H stands for hypotenuse. Okay, if you look at the triangle over here, and we label the angle theta here. So where does the opposite we actually refer to? Is it this, this, or this? Okay, so how to know where's the opposite? We will draw, we can draw a line like over here. Then we know that, okay, this is the opposite side. This is the opposite side. And then the hypotenuse is the longer side. So the last side remaining will be the adjacent side. So for example, if your theta is on this side instead, so your opposite will become here, will be this part. So let me repeat. If your theta is, okay, let's use this angle as Z. So if Z angle is here, your opposite will be at this side. This will be opposite instead of adjacent. So for this part, what I'm showing you is opposite is relative to the place that you put the angle at. Okay. So, okay. So for this tangent will be TOA, TOA. TOA refers to tangent theta is equals to opposite, which is O, over adjacent, letter A. For cosine, CA, so cosine theta is equals to adjacent over hypotenuse. And lastly, you guessed it, sine theta is equals to opposite over hypotenuse. Okay, so so for tangent, actually you do not have to remember, but you can also directly prove it if you want. So how does the proof go? So tangent theta is actually sine theta over cosine theta, and you will get the answer to be opposite over adjacent. Okay, so how does this prove is that since sine theta is equals to opposite over hypotenuse as shown here, and then we divide by cosine theta, so divide by adjacent over hypotenuse as shown here. Then by solving this equation and flip, so when you have a divide, you will change it to multiplication and you flip the numerator and denominator around. And you, by solving it, you will get opposite over adjacent. And that's the same as this tangent theta. All right, so now that you get sine theta equals to some opposite over hypotenuse, which is the value, how do you solve for theta? So usually we want to know what the value of theta is. Okay, so to get theta, we will sine inverse the opposite over hypotenuse. Likewise, we will solve for cosine theta. We want to solve for what is theta. We will cosine inverse this. And lastly, for tangent, we will tangent inverse the opposite over adjacent. Yeah, so for this table over here, this is some common angles and the values that is associated with it. So for example, sine 45 is square root 2 over 4. So it's square root. If you simplify it, it will be square root 1 over 2, which is equivalent to 1 over square root 2. All right. Okay, next. For this table, you can also key into the calculator to get the values of sine theta. So the next concept that we are learning or should know is the sine rule. So for the sine rule, and it can be used on all types of triangle. So A equals to sine A over sine A is equals to B over sine B, which is equivalent to C over sine C. So what does this mean? So if you look over here, this triangle here. So A, we can label A as the angle here. Then the opposite side will be alphabet A, which is the length. For B, it will also be the length, small b, and diagonally opposite, it will be the angle, big B. For C, length, small c, diagonally opposite, it will be the angle, big C. All right. So when alphabet, in this case, the big alphabet, the capital letters will represent angles, and the small alphabets represent a length. Okay, so for cosine rule, it can also be used on all triangles, and the formula goes in this way. A squared equals to B squared plus C squared minus 2BC cosine A. So where do you know where this A is, right? So this angle A will always be in between the two lengths, B and C. So for example, I have this unknown triangle, unknown portion that I want to find, which is angle A, which is here. So this is the one. Then beside it, we'll have B and C, B and C. And then A will be the small letter A is the diagonally opposite side. I mean the opposite side, yes. So just take note that this can be applied on all triangles. And next, for this bottom portion, it just means cosecant is the same as 1 over sine theta. Secant is the same as 1 over cosine. And cotangent is the same as 1 over tangent theta. So you can look at the third letter to know what is the letter of the denominator. All right, so that's it for trigonometry, where we learn about Pythagoras Theorem, tangent, cosine, and sine, how to find theta, sine rule, and cosine rule.